So in the first part of time value of money was the easy things. We talk about present value, future value, perpetuities, and then we talk about annuities and annuity formulas. We talk about ordinary annuities and annuity dues. So now let's try to go into more difficult stuff. In this one it says, assuming a 10% discount rate, how much would you pay for a 5-year annuity that begins by making the first payment today? So you have a 5-year annuity, so you have 5 payments, and all the payments are $100, as the timeline says. Interest rate is 10%. The first payment occurs today. So in this case, what is the worth of this annuity? The question asks. So what are we going to do? If I calculate, I can solve it in two ways, actually. So let me show both of them. The first one is easier to me. The second one might be easier for you. I don't know. So I will show you both of them. So basically, you have something like this, as you see in the time. That's why I say draw a timeline. So you have a 5-year annuity, and you have $500 payments. 1, 2, 3, 4, 5. Okay, 1, 2, 3, 4, 5. Okay. So in this case, I want to use the present value formula. Present value of the annuity will be payment times the interest rate. Interest rate is 10%. One thing to be careful about is how many payments do I have? I have 5 payments. Right? So if I use this formula will give me the value of this annuity at which time? The first payment occurs at time 0. So this formula will give me the value of this annuity at time -1. So since this payment is at time 0, this part will give me the value of the annuity at time -1. So what I need to do, I need to bring it 1 period forward by multiplying it with 1.1. So now this is the value. This is present value at -1. Altogether, it will give me the value of the annuity at time 0. So there should be the answer here. Okay, yes. So it should be like this. So this is an annuity due. The first payment starts at time 0. So the formula will give me the value of the annuity at time -1. So the formula gives me the value of these $100 at time -1. Since I'm interested in the value of the annuity today, I need to bring it to time 0 by multiplying with 1 plus r. -1 to 0. So this is the first way. This is how I solve this. The second way might be easier for you. So actually, this is what you can do. The same timeline. So you can say, okay, this is a 5-year annuity. The first payment is at time 0. I'm going to forget about the first payment for now. And I'm going to treat this as an ordinary annuity. Right? If I don't have this, this is going to be an ordinary annuity, right? Right? So I can again use my formula, present value, $100 payments. Let me just write PUGUFA. I don't want to deal with the wrong thing, long version, with 10% interest rates. And how many payments do I have in the structure? 4. So I have a 4-year ordinary annuity. So if I write it like this, this formula will give me the value of the annuity at which time? The first payment is at time 1. So this formula will give me the value of this annuity at time 0. Perfect. You're at time 0 already. What did I forget? 1 payment. And this 1 payment was at time what? At time 0. So if you calculate this part, it's going to be equal to $316.99, which is the value of the 4-year annuity, 4-year ordinary annuity, then you can add this $100 to your calculations, which happened today anyway. So it's going to be equal to 416. So this is the second way of doing things. Forget about the first payment first, then treat this as an ordinary annuity with 4 payments. But don't forget about the first payment. You have to add it back to your calculations. If this is too confusing, you can do the first part. Just treat it as an annuity due. Since the first payment is at time 0, the formula will give you the value of the annuity at time -1. So you need to bring the value from -1 to 0 by multiplying it with 1 plus r. They will both give you the same answer. Okay. Which one is easier for you? Who? Okay. Is there someone who's completely lost? Huh? Do you want me to go over it one more time? Can you respond? Are you there? Okay. Bless you.
Not completely lost, but moving too fast.
Moving too fast, okay. Let's go slowly. So basically, did you guys understand the structure of the question with the timeline? Okay, timelines are good. So you have a 5-year annuity, and the payments start immediately. Sometimes my students say, Hocam, it just gets confusing. So but it's actually not. When it says immediately, you don't even have to remember about, oh, is this ordinary annuity due? No, just draw the timeline. Your first payment is now. The only thing you should remember about present values is that the present value formulas gives you the lagged value of the annuities. What does it mean? If your first payment is at time 3, the formula will give you the value of the annuity or perpetuity at time 2. So in this question, the first payment is at time 0. So you can use the present value formula. The only thing to remember is, since the first payment is at time 0, the formula will give you the value of this 5-year annuity at time -1. I'm not interested in -1. I'm interested in time 0. Compared to -1, am I in the future or what? Compared to -1, 0 is future, right? So I need to calculate the future value. So I'm bringing the -1 value to 0 by multiplying it with 1 plus r, as we always did. We're time traveling the money, basically. So this is easier to me. If it's not, if you don't want to deal with it, you can say, okay, I'm not going to confuse myself. I have a 5-year annuity, okay, but this time, since the only problematic thing is the first payment, I'm going to forget about the first payment for now. And when you forget about it, this looks exactly like an ordinary annuity, right? The first payment is at time 1. You use your formula. So the formula gives you the value of this annuity at time 0. You don't have any problems here. You don't have to make any adjustments. You're done. But you calculated the value of 4-year annuities. You shouldn't forget the 5th payment, which is here. And it's already at time 0. You don't have to do anything to the cash flow at time 0. You're just adding it back to your calculation. So you calculate the 4-year annuity value at time 0. And since this first payment you originally forgot about is also at time 0, you are adding it back. So its value, the value of the annuity will be 417. If you solve more questions, I think you will be more comfortable. I think that's a good. I think I did a good job explaining it. I think you will get it once you solve questions. Let's just do this. Let's move on to this one. Then I will go to the future values things. The idea is kind of similar here, but there's no annuity due, ordinary annuity thing. And in the exam, if we don't say anything, it's ordinary annuity. Okay? How much would you pay to receive $100 every year for 4 years, but the payments don't start for 3 years? So it says you have an annuity, for a 4-year annuity. You have $100 payments. The payments don't start for 3 years. And what is the present value of this annuity? Again, draw a timeline, okay? When you draw the timeline, you know that the first payment will happen at time 3. And since you will have the payments for 4 years, you're adding 4 more years to your timeline. So you have 1, 2, 3, 4 payments. So in this question, I'm asked to calculate the present value. I'm going to do it in 2 steps. The first step, calculate the present value of this annuity. How am I going to calculate the present value of the annuity? Here, I have the formula here. So I have $100 payments. I have 4 payments, and interest rate is 10%. So you can just use this formula, and it will give you the value $317. Again, the same trick, not trick, some little thing you need to remember. Since the first payment is at time 3, the formula will give you the value of this annuity at time what? 2. Perfect. So that's the only thing you should remember when you use the present value formula. And draw a timeline, so it will help. So this will give you the value of the annuity at time 2. So what am I going to do? I'm interested in its value at time 0. What am I going to do to this? I'm going to bring it to time 0. How? How can I bring it to time 0? By dividing it. This one, right? You're bringing it 2 years back. This is not annuity anymore, right? You already calculated the value of the annuity. Now you have a lump sum payment. You're not using the annuity formula anymore. You're bringing it to time 0 using my ordinary present value formula. So this is the future value, 316 over 1 plus r to the power. What is t? Perfect. So it's a 2-step thing. You calculate the value at time 2. You take it to 2 years back. So the value will be 216. Any questions here? Don't read the second part. I'm going to go over it later. Any questions? Okay. So now, let's look at the future values. In the future values, remember, what did I say? The hints, the little thing to remember is, when is your first payment? The value this formula gives you is 1 period before the first payment. That's the only thing to remember. The trick about the future value formula, future value of annuity formula gives you the future value of annuity at the time of the last payment. So, yes. So if you have an annuity like this, the future value formula will give you the future value of these cash flows at the time of the last cash flow. So that's the thing to remember about the future value formula. That's it. So if I ask you a question like this, future value question, so it says, suppose you invest $429.59 annually at the beginning of each year, annuity due, at the beginning of each year at 10% interest. After 50 years, how much would your investment be worth? So if you draw a timeline, okay. So if you draw a timeline, it's going to look like this. So every year you put 429.59 starting from time 0, 1, 2, blah, blah, blah. You will have 50 payments, and the last payment will be here, 429.59. But the question says, after 50 years, how much would your investment be worth? So here you have N 50 years, 50 payments. But the question asks you, what is the value of this annuity at time 50? So what am I going to do? I'm going to use the future value of annuity question, annuity formula, which was future value is equal to payments 1 plus r to the power n minus 1 over r. So you have 429.59 times, what is the interest rate? 10%. 1.1 to the power 50, because you have 50 payments. So you're going to do this. This will give you the future value at which time? When is your last payment? So this is going to give you the value at 49. But I'm interested in the value of this annuity at time 50. So what am I going to do? I need to multiply it with 1 plus 1. That's it. So the answer will be 50. That's it. Okay, timelines are good. Draw timelines. It's good. Okay. Any questions? Then I'm going to go back to this example we just talked about. So if you remember, let's just remind you the example. How much would you pay to receive $100 every year for 4 years, but the investments don't start for 3 years? So what did we do? We drew the timeline. We had a 4-year annuity starting from time 3. If you remember, we calculated the present value of the annuity at time 2 and took it to time 0 using present value formula. You can also use future value formula, right? You don't have to go with present value. And some students find it easier. That's why I put it here on your slides. So if you use the future value formula, tell me the entries. So let me write down the formula here. Oh, it's here already. Okay, so future value is payments 1 plus r to the power n minus 1 over r. Okay, what is the payment? Huh? Huh? 100? Please respond. What is r? 10%. What is n? That's important. What is n? It's 4, right? Okay, students get confused here. It has nothing to do with the time periods we're in. It's number of payments, so it is 4. Okay. If you use this formula, it will give you the value of the annuity at which time? This future value. Future value. It's 6. When? Exactly at this point, right? When your last payment occurs at time 6, right? That's. So after calculating that part, then what am I going to do? I'm interested in the present value of the annuity. So what am I going to do? I'm going to bring it from time 6 to time 0 using my ordinary present value formula. That's it. Yes. Okay, because it was an annuity due, and you had 50 payments, and your last payment was at time 49. And you're right, this formula gives you the future value of the annuity at time 49, but actually the question asks me the value at time 50. That's why I had to make the adjustment. But in this question, nothing tricky here. You already know there are 4 payments, and the last payment is at time 6. And I'm just calculating the value of this annuity at time 6. But since the question asks me the value of it at time 0, I need to bring it from 6 to 0. That's it. So there, you don't have to worry about annuity due or ordinary annuity here. Because from the timeline, it's already very clear anyway. Anything else? Okay. Sometimes students find it easier because you don't have to remember about, oh, what is the present value, which time periods we are in, blah, blah, blah. So it might be easier for you. Okay, last annuity example before I start loan amortization. And this time we're going to calculate something different. How much do you need to put into your retirement account each year if you plan to retire in 30 years and if you will need $2 million? Interest rate is 12%. Again, I have the timeline. I'm going to retire in 30 years. And interest rate is 12%, and I know when I retire, I'm going to need $2 million. So every year, for 30 years, I'm going to make a deposit in the bank account. So this time, I'm not calculating future value or present value. The question asks me to calculate payments. How am I going to do it? We can use this formula. And let's use the table, actually, if we can. Oh, we can't because it says 30. But at least let me show you how you can use the table. So this time, I know the future value is 2 million. I don't know the payments. R is 12%. How many payments do I have? 30. So you need to calculate the payment from this equation. And if you do, the payment will be equal to 8.27. So every year, if you put $8,000 in your bank account for 30 years with 12% interest rates, when you retire in 30 years, you're going to have $2 million in your account. And if you don't want to deal with calculating this part with the calculator, you can always use the tables. And in this case, which table you need to use? You tell me. A1, A2, A3, A4. A4, right? Just find the formula which resembles your formula. That's it. So from here, you need to find number of years at 30. We don't have it here, but it should be 30. And then for the interest rate, find the 12%. So that number will give you this part. But if I were you, I would just use the calculator. I think it's easier to use the calculator. Because sometimes you find wrong answers, and I have no idea where your answers come from. And in the exam, please write down, like from the table, this is the table I used, this is the number I found. So at least I will know you're not making up numbers. Okay, any questions? Okay. Loan amortization. So I'm going to spend like 5 minutes on loan amortization, and then I'm going to talk about interest rates a little bit. So we're going to be done with this topic almost like completely today. And next Tuesday, I'm going to have the reviews. I will bring in-class exercise, and if you have questions, bring them to the class. So Tuesday, we can work on it. And then Friday, you will probably have 1 hour lab session in the morning. And in the evening, we're going to have the exam. And I will have extra office hours probably Thursday. Okay, so if you need me, I will be in my office on Thursday. Friday, it's hectic. Don't leave your questions to Friday. Probably you're not going to find me because you get crazy on the last day. So try to finish your studies at least most of it on Thursday. And the exam will be from 5 chapters. 1, 2, 3, 4, 5. 2 accounting chapters, blah, 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 parts to accounting chapters, and time value of money. Which one is the most important one? All of them is important, but time value of money is the first finance chapter. I don't know how many questions we're going to ask. I have no idea. Formula sheets, you don't have to memorize anything. Today we're going to have the meeting about the exam. We will provide you the formula sheets, like in the quizzes, or you will prepare your own cheat sheets. We're going to decide today. I don't know which one. I'm not asking your preference. I have an idea, but I'm not asking it. But I will let you know. So don't memorize formulas, basically. Okay. Last piece of energy with loan amortization. That's really important. Really important. Consider a 4-year amortizing loan. Loan amortization is an annuity thing. Okay. You borrow $1,000 initially and repay it in 4 equal annual year-end payments. If the interest rate is 8%, find the annual payment, blah, blah, blah. So what is loan amortization? It is something you use all the time. If you need money for a car, you go have loans from the bank. Mortgages are loan amortization things. So this is the thing banks actually use. So this is real life example. So these are pretty important. So in this question it says you have a 4-year, let's go over here. You have a 4-year amortization. So it means you're going to get some money from the bank, which is $1,000. And you're going to repay it in 4 equal annual year-end payments. This is what happens with the banks as well, right? So you're going to have something like this. 0, 1, 2, 3, 4. You have 4 payments. Payments, payments, payments. And initially you're borrowing $1,000. And the interest rate is 8%. So in the first part of the question says, find your annual payment. We know it very well now. It's an annuity question. I know the present value of the annuity. I know R. I know N. How many payments do I have? 4. I need to calculate the payment. So present value formula is over here. Present value is payment times this part. Okay. So present value is $1,000. I don't know the payment. Times, let me just, oh, okay, I write it. Interest rate is 0%, 8%. Okay. So if you do this, you will find the payment, which is $301.92. So if you borrow $1,000 from the bank today, and if you're gonna return the money to the bank in equal installments in 4 years with 8% interest rate, every year you need to pay $302 to the bank. There's nothing here. In the loan amortization, in those payments, some of the payment goes to the principal balance, some part goes to the interest payments. Right? When you borrow money from the bank, you are returning the initial amount, principal, $1,000. On top of it, of course, the bank gets some interest from you. Right? You're not returning $1,000 back. You're going to return something more than $1,000 because of the interest rate. Since your payments are fixed every year, the structure of payments are changing. It's not going to affect you, of course. You're making the fixed payment. But you need to know how much of the money goes as the interest payment, how much of the money goes as the loan amortization, the principal amount. So it says fill in the table. So we're going to fill in this table. You start with $1,000, your loan balance. And I know that every year you're making $300 payments. And every year on the balance you have in the bank, you need to, you're making the interest payment. Within the payment you're making, there's the interest amount in it. So since interest is 8%, the loan balance is $1,000. You got $1,000 from the bank in the first year. 8% of it, $80, is the interest you will pay at the end of the first year. Right? You borrowed $1,000 with 8% interest. So you're paying $80 as the interest payment to the bank. Is this part clear? Please respond to us. Okay. 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 So the payment you are making is fixed as $302. So the payment is this much, $302. $80 of it is the interest payment. So the remaining is basically the amortization of the loan. So 302 minus 80 will give you the amortization of the loan. how much you're reducing your original debt. So you borrowed $1,000, but at the end of first year, you reduced the original payment to by $222. So when you start the following year, your loan balance is not 1,000 anymore. It's not 1,000 minus your payment. It is 1,000 minus the amortization of the loan. So I'm separating interest and amortization. So 1,000 minus 222 will give me the loan balance of 778. Then the interest I'm paying for my debt will be lower because my original debt is reduced by the loan amortization. So again, I'm multiplying this with 8% interest rate. 8% is the fixed interest rate. So in the second year, I'm paying $62 as the interest. My total payment is again fixed, it's 302. This time, less of the payment is going as the interest payment. More of it is going for the loan amortization. So this time, 302 minus 62, 239 is the loan amortization. How much you reduced your beginning of the year loan balance. So in the following year, 778 minus 239 will give you the original, will give you the loan balance. Then you're calculating interest, blah, blah, blah. So every year you are doing this. At the end of the fourth year, of course, your loan balance should be equal to 0. You should pay all of your loan back. So what are the important things about loan amortization? One, you're calculating the payments. It's fixed amount of payments. Your payments will never change. The structure of your payment changes. Part of the payment is interest payment. Some part is loan amortization. You understand the interest payment, right? That part is easy. Do you understand what loan amortization is? It's how much you're reducing your original debt. How much you're eating away from this 1,000. So every year, since your original debt is reducing, you're paying less interest, and more of your payment goes as loan amortization. So it's like this. So here, let's say you have a 30-year loan. These are the payments you're making. When you begin, most of your payments are interest payments because your original balance is huge. But then you pay less and less as the amount you pay is fixed, but within it, the interest payments get lower. More of the payment goes as the amortization of the principal. So this is a loan amortization. Any questions here? Okay, so in the last part, this is also a nice thing to see whether you got the idea or not. Show that the loan balance after 1 year here is equal to the year-end payment of $301 times 3-year annuity factor. Annuity factor is this part. So basically it says, show that after 1 year, the value of annuity is equal to a 3-year annuity with $302 payment. Since it says show that, you don't have to calculate anything. You just need to show what it is. So after 1 year, how many payments is left? After 1 year, how many payments you're left with? 3. What is the amount of payments? Level of payments? Amount of payments? 302. So after 1 year, your payment is 302 with 8% interest rate. You have 3 payments left. So if you calculate the value of the annuity at time 1, it will be equal to 778, which is exactly this number. So basically, it's trying to say the value of the annuity every year will be equal to how many payments you're left with. That's it. So it's always annuity structure. Nothing changes. This was an exam question before. This part, especially. It wasn't show that. It was something you were supposed to calculate. Any questions? Let's go over the interest. Let's talk about the easy things again. And then we're going to finish the lecture today. Okay. This will be like a nice breeze for you. So we talk about interest rate all the time. And as I said in the beginning of today, interest rates have all kinds of information in it. It has the inflation in it. It has the reward for waiting and not consuming today in it. And it has the risk information in it. So it has all kinds of information. And when I say interest rates, we are talking about two things. There's the simple interest and there's compound interest. And I think some of you already know the difference. What is the difference between simple interest and compound interest?
Compound'da semi falan oluyor.
Huh?
Semi oluyor mesela. Compound
The easier. I'm asking about the easiest difference.
in compound interest, we use the money that the interest comes, and we run that money with the interest.
So basically she says in the compounding you're making interest over interest. In the simple interest it's not the case. So you earn the interest and you're removing it from the bank, let's say. In the compound interest you make interest, you keep it in the bank, you make money over the interest as well. So in this class we're always using compound interest actually. And this is the difference between the two interest rates. Interest earned at a rate of 7% for 5 years on a principal balance of 100. So you start with $100 value. And since the simple interest is 7%, every year you're making $7. Okay, that's it. So the amount you have in the bank increases by $7 every year. That's it. So at the end of 5 years, the money you have will be equal to 135. Every year, you're earning the simple interest of $7 on the original amount of money you have in the bank. This is simple interest. In the compound interest, things will get different. In the compound interest, since at the end of the first year, the amount you have in the bank became 107, now you're making interest over 107. Not 100 anymore. So you're making more than $7 in the second year because of the compounding. You make interest over interest. So every year this compounding increases. So at the end of 5 years, the money you have in your account will be equal to $140. As expected, with the simple interest, the money you earn is less than the money you would earn with compound interest. Why? Because you're making interest over interest. So this is the basic difference between compound interest and simple interest. The value of the money you have in the bank grows constantly when you have simple interest. With compound interest, it grows at an accelerated rate. Why? Every year you're making more interest, therefore you're making more money over interest. So using compound interest makes sense if you're the person who is giving the money, of course. Something more difficult to understand is effective interest rates. Again, you need to wake up. This part is again important after that easy breezy part. So basically, in the effective interest rates, we're going to consider compounding as well. Normally, what we use is the annual percentage rate, interest rate that is annualized using simple interest rate. In the annual percentage rate, we are kind of ignoring compounding. But if there's compounding, then effective annual interest rate will be different than the annual percentage rate, actually. So let's look at this one. A stated rate of 12% with monthly compounding. So from the bank, you got an APR for 12%, and it says monthly compounding. It means every month you're going to make 1% interest, right? 12% per year means 1% per month. From the stated rate, after finding the monthly interest rate, I can calculate how much money I'm going to have in my bank account after 1 year. So if you deposit $1 today in the bank account, and if you have monthly compounding, it means every month you're gonna make money over the interest you earn. So the month interest rate is 1%. You're putting $1 in your bank account, and there are 12 compounding, 12 periods in 1 year. So at the end of 1 year, your $1 will become $1.12. So the return you obtained is not 12%. It's not the simple interest, actually. It is more than that. It is 12.68%. $1 became 1.12. So your return is 12.68. Why is there this difference? The simple interest was 12%, but you made more than 12%, 12.68. Why? Something very simple. Because of the interest of interest, exactly. Since you have monthly compounding, every year the bank makes you earn interest over the interest. So this was the effective annual rate, actually. So how do you calculate it? We have a formula. Effective annual rate will be calculated like this. 1 plus the annual percentage rate over M. What is M? It's number of compounding per year. To the power M minus 1 will give you the effective annual rate. Let's look at it over examples. So suppose that 10% is the stated rate or annual percentage rate. And with different compounding periods, we're gonna calculate the effective annual rates. So if you have annual compounding, so you have 1 compounding per year, in this case, your effective annual rate will be equal to annual percentage rate. Nothing will change. So you have 1 compounding per year, M will be equal to 1. APR is 10%. So effective annual rate will be equal to 10%. If you have semi-annual compounding, it means every year you will have 2 compounding. So in this case, what's going to happen? You're making 10% annual percentage rate, but you have 2 compounding per years. So your semi-annual interest rate is 5% basically. And since you're leaving your money in the bank for 1 year, you will have 2 compounding. Every 6 months, you're going to have a compounding. So you use to the power 2. So effective annual rate becomes 10.25%. The more compounding you have in a year, the more return you're going to get, of course. If you have monthly compounding, you will have 12 compoundings every year. So M will be equal to 12. So effective annual rate will be equal to 10.47%. You might have daily compounding. So you might have 365 times compounding. In that case, effective annual rate increases. The last one is the continuous compounding. Every second there will be compounding. And of course, in this case, the formula will change to something like this. And the effective annual rate will be the highest possible. There's some rounding here, so you don't see it here. But the more compounding you have, the more return you're gonna generate, basically. And it's the formula you're gonna use. So that part is important because effectively how much money you're paying is important. And let me just go over this one, and I will leave the real versus nominal interest rate part to Tuesday. So credit card statements. Banks use this all the time. So you get monthly rates. It says if you don't pay your debt, the monthly rate will be 1.65%. Or they tell you annually, the annual rate is 19.8%, which is 1.65 monthly interest rates times 12. But if you calculate effective annual rates, the rate you're actually paying to the bank, it will be more than this because of the compounding. So here APR is 19.8 over 12. So this part will be the monthly interest rate. And since you have 12 months in a year, you will have 12 compounding. So the effective interest you're paying to the bank will be 21.7% actually. So banks do this all the time. You need to be careful about it, whether they're giving you the stated rates, simple rates, or not. Whether there's any compounding is a question you should ask to the banks every time you borrow money from them. Okay, any questions? Then I will let you go. So for Tuesday, we're going to have a review. I'm going to talk about real versus nominal interest rates for 10 minutes or so. Then we're going to solve some questions.